guys, and welcome. Today, I wanted to talk about a really interesting topic that will become more viable the further we go in our space programs. And with contributions from private entities such as SpaceX and Blue Origin, we'll have certain results from them rather sooner than later. Those are interstellar space flights. First part that will greatly contribute to it will be development of lunar and Martian bases, particularly lunar, and expanding them to full-fledged colonies with an establishment of a permanent industry in there. It will go all the way from extracting the resources from the lunar soil to actually producing the necessary parts for spaceships that will go in our solar system and hopefully beyond. Second part would be the development of faster modes of transportation. And theoretically, we know that it should be fusion drives and more developed versions of ion thrusters. We have certain initial prototypes and schemes for those. And quite certainly over the next 20, 50 years, by the time we have sizable lunar and Martian colonies, we will have those fusion drives and ion thrusters in more developed version, which will speed up all the space travel 5 times, 7 times, or even faster. And they will allow us to actually practically consider interstellar space flights, since other solar systems will be reachable in meaningful amounts of time. Third part would be gradual development of sublunar space stations, and they will serve as the primary nodes for space flights across all the solar system. And from that, they will be developed into dry docks for humongous interstellar spaceships. And if all those three components are met, we will start creating something based on O'Neill cylinders with all likelihood with artificial gravity technology that will be also large enough to sustain big populations indefinitely. Why this topic is viable, why is it important, is because over the next 100, maybe 200 years, sooner or later, we will face problems of overpopulation, and we will have certain reduction of available resources. And this will all contribute to reduction of our living standards. It's something that Garrett O'Neill has already talked about, and Jeff Bezos has also mentioned in his presentation of the origin, and it will definitely happen sooner than later, and hopefully later, of course. And with all the available options, going to space and colonizing other planets is probably the most fulfilling and the most interesting one. And it will open new horizons for development of humanity. And I'll briefly outline some of the previous subjects that I've touched in my last videos, such as terraforming other planets and industrialization, and I will go deeper into other aspects of interstellar transportation and how we can achieve it.
First of all, I will go through the modes of interstellar transportation, since they would be the key to determining all the necessary starship configurations and the resources required for them. Second, I will briefly outline the necessary infrastructures that we have to be created on the moon in order to support the full-fledged starship construction. Third, I will talk about the necessary factors and concepts that would have to be put in practice when constructing the starships to make them best suited for long-term journeys to distant exoplanets. Let us begin with the propulsion methods. They can be split into the relatively close ones that are currently under development and the more distant ones that are further away and harder to achieve. The first would be the fusion drives and ion thrusters. The later would be the antimatter drives, black hole drives, Alcubierre warp drives, and traveling through wormholes. Those are currently harder to accomplish and would need time and effort to become energy efficient. They would have us delve deeper into the laws of time-space and require solutions in the subjects that we're only just starting to tackle in scientific fields. On top of that, they would be the fastest mode of transportation. That would be the next step in traversing the universe, since that would allow us to get near the speeds of light and even surpass them. And those are the ones that I'll be discussing in part 2. And in the current part, I will discuss fusion drives, ion thrusters, and how it all comes together with O'Neill cylinders and lunar industry. The nearest mode of transportation that would go extremely well with Mars and Moon colonies are the fusion drives and ion thrusters. The helium-3 that is abundant on both Moon and Mars to become the perfect fuel for such engines. As I mentioned in my previous video, we are steadily getting closer to developing small and medium scale fusion overall. But to be specific, NASA is currently working on developing a certain space engine. NASA funded joint venture between the University of Washington in Seattle and a small company named MSNW LLC is focused on the development of advanced space propulsion systems and have developed a small field reverse pulse fusion device that can be turned into a fusion drive engine with a particular aim on the deep space travel, while Princeton's Plasma Physics Laboratory is in collaboration with a company called Princeton Satellite Systems, working on a fusion drive engine for space exploration. 2 years ago, NASA awarded $500,000 grant to the venture that was distinguished by U.S. Federal Laboratory Consortium award in October last year. For those reactors, the deuterium or helium-3 reactions are planned with the reaction being unelectronic, requiring no heavy shielding for protection. Once used for traveling to Mars, it will be able to cut the time of such journeys to one-third of current time, going at the speed of up to 350 kilometers per second and reaching Mars in 90 days and most likely even less. And we're talking only about the initial stage of development, while in all likelihood the technology will become more efficient and allow us to reach greater speeds as it becomes more refined. The next important component of space travel would be the ion thrusters. By using the electrical power efficiently, the spacecraft will be able to travel further and faster, with maximum speed going up to 90,000 meters per second, over 200,000 miles per hour. In comparison, the space shuttle was able to reach only 18,000 miles per hour, coupled with fuel efficiency of up to 90% compared to 35% of chemical fuels, will be best suited for interstellar space travel, particularly if spaceships will be constructed in Moon's orbit, and this will be detailed further since they will cut down the costs of transporting all the materials from the Earth dramatically. And if we have the lunar industry, we can get all the necessary resources from the moon. For the long-term journeys, even the smallest thrust can add up to a much shorter travel time and fuel consumption. That's why ion thrusters are quite important at the current stage. As their name says, ion thrusters eject ions instead of combustion gases to create thrust, and the applied force makes the spacecraft move forward. The ion being an atom or molecule that has an electrical charge because it has lost positive ion or gained a negative ion and electron. In the case of ion propulsion, they have lost electrons, thus they are positively charged. Plasma is an electrically neutral gas in which all positive and negative charges from neutral atoms, negatively charged electrons, and positively charged ions add up to zero. It is four states of matter and exists everywhere in nature. It has some of the properties of gas, but is affected by electric and magnetic fields, making it a good conductor for electricity. In ion thrusters, plasma is made of positive ions and equal amounts of electrons. NASA's conventional method of producing ions is called electron bombardments. The propellant is injected into the ionization chamber from the downstream end of the thruster and flows towards the upstream end. The injection method is preferred because it increases the time that the propellant remains in the chamber. There would be a need to develop ion thrusters powerful enough to propel the humongous interstellar spaceships. Thankfully, with fusion drives that should work on helium-3, it will be possible to significantly decrease the fuel requirements and maximize efficiency. This will all tie together well with the amounts of potential fuel on both Moon and Mars, particularly at the Moon, since we would have to construct the spaceships at the sublunar or lunar stations, where there is far smaller pool of the gravity and to where the resources can be transported at a far smaller cost. I have discussed the possibility of establishing permanent settlements at the Moon that would be coupled with industrial complexes, providing all of the necessary protection for inhabitants and particularly from radiation, and utilizing robots for both surveying, construction, and possibly even for resources extraction that would minimize human exposure. This can go as far as establishing underground cities with artificial lighting and ecosystems under the lunar surface. Those would be the first step in space exploration, and coupled with the first technologies to spread life to the lunar surface, we would be able to even get the required terraforming technologies that we would definitely need to create livable conditions on other planets. So as to be going from getting the first greenhouses on both Moon and Mars to using the silica gel and oxygen producing bacteria from Earth to starting and reshaping other environments bit by bit. With additional technologies being developed, the further we progress in expanding extraterrestrial settlements. Therefore, both lunar and Martian programs would eventually yield results in technological development that be usable by the larger interstellar program. On top of that, there would be an established logistical route of reusable space transportation. This would be realized by considerable effort that is being put into reusable rockets by both Blue Origin and SpaceX, coupled with NASA's effort to create a sublunar station, lunar orbital platform. We will have the initial step towards a larger goal of interstellar spaceflight. The Lunar Orbital Platform is meant to serve as the initial base for the site selection and mapping of the lunar surface. Will be developed into a larger docking station for all of the space flights in the solar system, including Mars. Once is reached together with a considerable expansion of the lunar base from a single enclosed living capsule to a full-fledged industrial complex, we'll be able to start working towards interstellar spaceship construction. The moon has abundant metals and minerals and helium-3 to provide us with everything that we will need for the construction of annual cylinders. We will also have to consider that it won't be a single spaceship. We will have to establish a permanent industrial production of such. Therefore, the moon will eventually become a forward base for all of our space travel and will, as all likelihood, be transformed to sustain life in its all fullness. It would be the perfect testing ground for all of such environment changing green technologies that would gradually terraform, and they would provide available resources for humanity for any occasion of recreating ecosystems in other planets or in places where life has previously not existed and that were deemed inhospitable. The cylinders and starships themselves would be the pinnacle of human engineering. So it would have to be a part of the Earth that is completely habitable, sustainable, and can exist independently for an indefinite amount of time. It should be created with a goal of being as livable as our Earth is, with all of the necessary technologies to maintain the water circulation, the full atmosphere, and day and night cycle, which is achieved by large windows that will be splitting the cylinders, not to mention it being completely sealed and heated. With the current rate of robotic technology development, we would probably expect a complete automation of most of the manual labor and tasks. Therefore, freeing all the inhabitants from the burden of manual labor and removing most of the need for it for maintaining the ecosystem. Coupled with all of the recycling technologies, we will have a very clean biosphere that can sustain itself indefinitely. Once developed, all of those technologies can be replicated on Earth, making everyone's life easier and making our environment cleaner. The spaceship structure would consist of two cylinders rotating in opposite direction on a bearing to mitigate the gyroscopic effect. With each cylinder proposed to be 20 miles long and 5 miles in diameter, each divided in six large section stripes, three windows, and three habitable zones. The industrial recreational facilities will be placed on the central axis in a zero gravity environment. As those two giant cylinders rotate around their axis, they would be bringing into action the centripetal force of any object in the inner surface and create artificial gravity. The acceleration would be a substitute of acceleration on Earth, and given that it would rotate roughly 28 times per hour to simulate an appropriate gravitational force. In addition to acceleration, the cylinders are designed with ratio of gases similar to what can be found on Earth. It's how we can recreate the atmosphere. So the pressure would have to be half of that at sea level. This wouldn't impact our breathing substantially, but it would bring down the need for gas and the construction walls in general. The proposed cylinders would also have provisions wherein its habitat would be able to control its own microclimate through an arrangement of mirrors and by altering the ratio of gases in the cylinder. The cylinder would have to become huge thermos if we are to survive the cold space between stars. That's the part where the mirrors that capture sunlight would play their biggest role, enhancing the amount of sunlight that we would receive. It can be concluded that there is a humongous potential for space travel, and we would definitely see considerable progress in spacefaring technologies the further current space programs develop. We will quite certainly see the fusion drives in the near future, and with dedicated amount of resources and scientific thought dedicated to the subject, we should be able to start approaching the more extraordinary methods of space transportation. The most interesting point to look forward to after we make the initial colonies on the Moon and the Mars would be establishment of extraterrestrial industrial complexes, as previously mentioned. Those would be the first steps towards interstellar exploration. With all likelihood, we will see some considerable progress in the next 20 to 50 years, coupled with greenhouses established on other planets and gradually expanded, and our first attempts at terraforming that should be yielding us a more defined vision of how interstellar colonization will look like. This is the end of the first part, and in the second part, we'll discuss more exotic modes of transportation, including Kugelblitz, warp drives, and even wormholes. And the reason why I decided to split it to the second part because spaceships that will need to be constructed then will look entirely and completely different, and we're just beginning to theorize about them. And we will need something as humongous as on all cylinders, since spaceflight will possibly be even faster than the speed of light. Thank you for watching the video. I really hope that you enjoyed it. If so, please give it a like and subscribe to the channel for more videos like this. You can read my entire article on the subject by following a link below.